Hi guys, over the last few weeks we've been looking at part-whole problems. This week we're moving on to something slightly different. Here we're learning to analyse and solve division problems. Now in each of these problems we're going to know the whole amount, but what we won't know is either the value of each part or how many parts there are. And we're going to use either shading or grouping in order to solve these. To begin with, let's get thinking. Here I've got a statement, and what I'd like you to do is discuss with your partner whether you think it's true or false. But remember, it's important that you're able to justify your thoughts by giving reasons why you think it's either true or false. The only way to solve this problem is using division. And here's the problem. 28 children turn up for a Quidditch practice. Madam Hooch wants to make teams of 4. How many teams can she have? Do you think it's true? The only way to solve that is using division, or is it false? No, I can solve that using different ways. Pause the video for a couple of minutes, discuss your thoughts with your partner, and then be prepared to share your reasons with the rest of the class. Let's have a think about how we might solve this. So to begin with, I'm going to start with my 28 players, and I'm going to use a number line to record what I'm doing here. What Madam Hooch might do is she might take 4 of those players to make the first team. So we're now got 24 left. And then the next 4, there's now 20 left. The next 4, there's now 16 left. The next 4, there's 12 left. Next 4 again, and there's 8 left. 4 again, and there's 4 left. And we can make a final team with those last 4. So you can see there, we've got 7 teams all together. Now we solved that by counting back in groups of 4. Let's have a look at another way we could have solved that. We're going to start with our 28 players again, only this time we're going to look at it in a slightly different way. To begin with, we have got no players in a team. So let's take those first 4 players, and now there are 4 players in a team. The next 4 players, we've now got 8 players in 2 teams. The next 4, we've got 12 players in 3 teams, then 16 players in 4 teams, 20 players in 5 teams, 24 players in 6 teams, and 28 players in 7 teams. We get the same answer, of course, only this time we didn't count back from 28 in groups of 4, we counted on from 0 up to 28. Could we do that more efficiently? Could we do that giving ourselves less work to do? So let's start with our 28 players again. And this time I'm going to count on. So rather than doing it one at a time, I might think to myself, well, I know that I've got enough for 5 teams there. And 5 teams would be 20 players. I've only got 8 left. I know I can have 2 teams with those 8 players. So I get my 7 teams once again. Only this time I didn't count on in groups of 4 one at a time. I counted on 5 groups of 4 and then 2 groups of 4. So I've still counted on, but I've done it in a more efficient way. Before we get on with our investigation this week, I'd like you to have a think about the following. How many different correct answers can you find for 27 divided by 4? So pause the video for a couple of minutes, discuss with your partner to see how many answers you can come up with that correctly answer that number story. I'm not going to share my thoughts right now. I'm going to let you investigate this using some different problems. So to begin with, 27 chocolate bars have to be shared equally between the 4 professors. How many should they each get? Next question, 27 Lego figures have to be shared equally between the 4 professors. How many should they each get? 27 pounds has to be shared equally between the 4 professors. How much should they each get? And lastly, 27 people need a taxi to the airport. A taxi holds 4 passengers. How many taxis should they order? I'd like you to pause the video for 8 to 10 minutes and investigate those problems with a partner. Can you use bar models to help you analyse each problem? Can you use resources in order to solve them? And can you explain that thinking by drawing pictures and diagrams? Hopefully you've had a go at those, you've been able to analyse and solve them with a partner. Now initially when you read those questions you might have thought to yourself, why is he asking me the same question 4 times? I'm going to get the same answer to each of those. However, when we analyse those problems, we might find something different. Let's start with the first one. 27 chocolate bars have to be shared equally between the 4 professors. How many chocolate bars should they each get? Now to begin with, I'm going to start with my whole amount, which is my 27 chocolate bars, and I'm going to draw the bar to represent that whole amount. I know I've got 4 professors, so I'm going to split that bar into 4 parts. The next thing I need to do is make sure they've got equal shares, so I'm going to start sharing out those chocolate bars. Now I could do that one at a time, but that's going to take me quite a while. I can see there that I've got enough to give them at least 4 each. So let's start by sharing out 4. I can see I've still got quite a lot of chocolate bars left. I can now see that I've got enough to give them 2 each. So I've given each of them 6 so far, and I've now got 3 chocolate bars left. Now you might say the answer to this question is 6 bars each, and there are 3 chocolate bars left over. You would be perfectly correct if you said that. But is there something else we can do with those chocolate bars? Well, we could share them out. We could break them up into parts. I think I'll start by splitting them into quarters. So let's get rid of these 3 whole chocolate bars and let's replace each of them with 4 quarters. You can now see I've got 12 quarters altogether, so I can give each of those professors 3 quarters of a chocolate bar. How many chocolate bars do each professor get here? The answer is 6 whole bars and 3 quarter bars. Let's have a look at the second problem. 27 Lego figures have to be shared out equally between the 4 professors. How many should they each get? Again, we've got 27 things to be shared out between the 4 professors. Surely we're going to get the same answer. Well, let's have a look. Let's begin by drawing the bar to represent the whole amount. We've got the 4 professors, so let's split that bar into 4 parts. And once again, let's start sharing out. I can put 4 into each of those, like we did the first time. And then I can give them a further 2. Just like we had with the chocolate bars, we're left with 3 Lego characters. The only difference is this time I can't cut a Lego character into quarters. So in this case, we cannot get an answer of 6 3/4 each. This time we can only give each of them 6 Lego characters and there are 3 left over. I can't give them to any one of the professors because then it wouldn't be fair, so we're going to have to leave those as spares. So the answer this time is 6 figures each, and there are 3 left over. There are 3 spare. Let's have a look at the third problem. This time we had £27 to be shared equally between the 4 professors. How much should they each get? Once again, let's draw our bar to represent the whole amount. We're sharing between the 4 of them again, so let's split that bar into 4 parts and let's start sharing out that money. Now, right away, I could give each of them £5. Then I could give each of them £1, so they've got £6 each, just like we've done in the previous 2 problems. And this time, we've got £3 left. Now, what can we do with that £3? We can't give it to any one of them because then it wouldn't be fair. We can't give £1 to 3 of them because one of them is going to be left with £6 while the others have 7. So what can we do? Well, because it's money, we can get change. Let's get 50 pences for those £3. So now I've got 6 50 pences. So I've now got enough to give each of them 50 pence. And I'm left with £1. Now I can't share those 2 50 pences out between the 4 professors, but what I can do is go and get change again. And this time, let's change that into 20 pences. So now I've got 5 20 pences. I've got enough to give each of them 20 pence. I've got 1 20 pence left. Let's change that for 5 pences. I've got 4 5 pences, which I can share out. I've shared out all of the money. There's no money left over. And this time, each person has got £6.75. Let's have a look at the final problem together. 27 people need a taxi to the airport. A taxi holds 4 passengers. How many taxis should they order? So there's my 27 people waiting on a taxi. And this time is slightly different because I don't know how many parts to split that into. I don't know the number of taxis I need. So what might I do first? Well, we might order a taxi. How many people can get into that taxi? 4 people can get into the taxi. I've still got 23 people left, so what can we do next? Let's order another taxi and another group of 4 people. And we're going to keep doing that until we're left with those 3 people again. We've got 6 taxis ordered so far, just like we got the answer to each of the previous problems, and we've got our 3 remaining. Now this time, those 3 people still need a taxi, which means we're going to have to order a 7th taxi for the 3 of them. Now that we've done that, all 27 people can get to the airport, and we've needed 7 taxis in order to do it. Each of those problems that we looked at were based on the same number story that we introduced earlier on, 27 divided by 4. We solved those using 2 different strategies. We shared for the first 3 and we grouped for the last problem. And what determined that choice? The context of the problem itself. So the first 3 we had to share chocolate bars, Lego figures and money between 4 professors, so we naturally shared. The last problem, we needed to find out how many taxis, and we knew that each taxi could hold 4 people. So that meant that we naturally grouped 4 at a time. Not only did we use different strategies, but we came up with 4 different answers there. The first problem, when we were sharing 27 chocolate bars, we found that we could give each of the professors 6 whole bars and 3/4 of a bar, because we could cut those bars into quarters. When it came to the 27 Lego figures, well, we couldn't cut those remaining 3 Lego figures into quarters, so therefore it was only fair to give them 6 figures each and have those 3 left over. When it came to sharing out the £27, once again we were able to give them each £6 and we had that £3 remaining. But because it's money, we can change those pounds into pence, so we're able to give them each £6.75. And finally, for the 27 passengers who we needed to get to the airport, once again we were able to fill 6 full taxis and there were 3 people left over. Now those 3 people still needed a full taxi, which means we needed 7 taxis in all. So we've got 4 different answers to the same basic number story. And what determined those answers? It was the context of the problem itself. It determined the strategy that we used, and here it actually determined our answer. So it's really important that when we're exploring division, we do that through problems in order that we can help make decisions based on the problems themselves. It's time to have a think about our success criteria. So what I'd like you to do is pause the video for a couple of minutes and have a think about how did we achieve success? What were the steps that we went through in order to solve each of those problems? Hopefully you've had a chance to discuss that and you've come up with the success criteria for analysing and solving division problems. Here are my thoughts. For each of those problems, the very first thing we had to do to begin with was choose a strategy, whether we were going to share or group. And that decision was based on the context itself. Now let's have a look at sharing to begin with. The first thing we needed to do when we made that decision to share was draw the bar. We can draw that bar to represent the whole amount, and in this case it was the 27 action figures. Once we've drawn the bar, the next thing we need to do is decide how many parts. For this problem, we were sharing those figures between 4 professors, so we needed to split that bar into 4 equal parts. Once we've done that, we can then share out fairly. Now, we didn't do it one at a time in this instance. We shared out 4 each and then 2 each. So we did it more efficiently. We were left with 3 extra, which we knew we couldn't share out because we couldn't split them up. So the last thing we need to do is just count up those shares. So in this case, we had 6 figures each and 3 spare. Let's have a look at grouping. For the grouping problem, we had 27 passengers who needed to get to the airport and we wanted to know how many taxis they would need. Now in this case, we couldn't draw the whole amount we couldn't draw that whole bar because we don't know how many taxis. So what we did in this instance was we drew a part. We knew there were 4 in each part, so we can start by drawing that part, and then we can take away a group of 4, and in this case put them in the taxi. That meant there were now 23 people left. We needed a taxi for each of those. So we repeated that as many times as possible. We got another group, and then another group, and then another group, until we had filled 6 taxis. We then had those 3 remaining, but we knew in this instance we needed an extra taxi for those 3. So all that remains to do is count up the groups, and in this case it was 7 taxis that we needed. It's time to try that out. Can you apply the success criteria that we've just developed to analyse and solve the following problems? Once again, we've got mild, spicy and extra hot problems. If you're going for the mild, you're going to go with the yellow numbers. Spicy, you're going with the green numbers. And extra hot, you're going with the red numbers. So if I'm doing the first mild question, then it reads, the Weasleys buy 6 tickets to the Quidditch World Cup. They pay a total of £39. How much does 1 ticket cost? Second question, if I was to do the spicy, 120 chocolate frogs are to be shared equally between 7 boxes. How many should there be in each box? And question 3, if I'm going to go for the extra hot, a carriage on the Hogwarts Express holds 8 passengers. How many carriages are needed for 262 passengers? Once you've done that, you can make up 3 problems for someone else to analyse and solve at your table. Pause the video for 10 minutes or so, analyse the problems by drawing the bar, can you solve them using resources, and can you make your thinking visible by drawing pictures and diagrams. Next, it's time to reflect on the following questions with a partner. So once again, pause the video for a couple of minutes and have a think about the following questions. What have you learned today? What did you find easy or difficult? Did you get stuck? What helped you when something got tricky? What do you need more help with? What is really making you think? And what are your next steps? The last thing I'm going to ask you to do today is, can you apply what we've learned? So as a class, I want you to discuss, analyse and solve the following problem. Each table at the Yule Ball has space for 14 seats. How many tables are needed for 180 guests? Thanks for taking part today. Hopefully you learned something. Hopefully you found that useful. You can contact me at scott.morrow@southayrshire.gov.uk, or you can tweet me at scottmorrowsa if you've got any questions or you'd like to share your solutions for today. Next week we're going to be analysing and solving multiplication problems, so I hope you join me then.